Well, there's only 3 people here. Also, privacy policy, I'm recording this meeting.
Okay.
I'm not. That doesn't give you an excuse not to come.
Just put it in you should just say that when you're
Oh, I
on the
didn't
chat.
I didn't want to say it before.
Also,
because then
yeah.
people will just not come.
Yo, do you have announcements set up for Teams?
Okay,
Or
so
reminders?
yes and no. So
Because
they kind of disabled some of that because people were getting spammed. Because everyone is, it's like all public channels for some reason.
yeah, that's weird.
Yeah.
Because
So
I see 13 hidden channels, so I'm getting messages from like all of them.
yeah, we're still trying to figure that out. I have notifications and shit turned off for Teams.
Wait,
No, I have notifications on, but I don't get notifications for the other channels.
Wait,
Only when they have meetings.
No, JK. If you hide the channels, you don't get their notifications.
Yeah, that's what I
Okay,
thought. Because I haven't been getting notifications.
Because I saw electronics and I was like,
Wait, are you guys seeing my Teams or are you seeing just the presentation?
No, I see it. No, I see
Wait,
your presentation.
You don't see my Teams?
No.
Okay, perfect. That's what I want to see. Nice. There's like the 2 people who live with me aren't here.
No, Teams is pretty sick, yo. I had to use it for a full week.
Oh look, Brian Brown is here. Okay.
Nice.
2 more minutes. How was everyone's day? How are you guys? How's your week? First week of school?
11 more to go. Let's go, boys.
11 weeks? Really? That short?
Yeah. No, it's like 13 weeks normally, but then like one's gone for reading week. So there's like 12 whole weeks, and then we finished one.
That reading week better be worth it.
Trust me, 3rd year, it's going to be so worth. But even the 2nd year, it's definitely not worth. Kiki, can you imagine them stacking all the midterms into like 1 week after reading week just because?
Yeah, I could not. Oh, they removed like it's not. They stopped calling them midterms because they're not allowed to call them midterms, but they're basically midterms. They called them assessments.
Yeah, they're all assessments.
By the way, have you guys had a chance to review the meeting agenda for today?
No. Where even is it?
No.
Sorry, Carter, go.
Oh no, I was just asking where is it. I'm sorry, I didn't know about it.
Oh, so none of you guys knew about this? Okay. Have you guys been checking the teams at all? I'm not gonna be bad if you don't. Just be honest.
No, not really. I mean, I just reviewed the textbook chapter they told me to review.
Okay, so where main communication is all gonna happen in Teams. So like if I send, because I don't want to like write emails to everybody. I don't think you want to be receiving emails from me.
Yeah.
So it's like, so Microsoft Teams, if you haven't gotten it already, I will send you an email about it. I'm pretty sure I've added you because you're able to join this meeting.
If they're not guests in the channel.
Yeah. So if you go, Actually, I will show you. I will show you in this presentation how to do all that.
Alright.
So yes, welcome to our first official meeting. I know we've had meetings before this, during the year, but they were like not like just energy systems, and there's a lot of other things going on. So finally, we are having our first ever official meeting. Welcome. So first thing I'd like to touch on is how we're going to communicate as a team and moving forward as an organization, within our energy system subsystem. So our meetings will be 11 a.m. every Sunday, and I want them to be only half an hour, like rapid fire updates. Of course, at first it's going to be longer because you're still trying to figure out like what you're doing. Like for this one today is the one chance where I'm going to say, okay, it'll be like an hour because we have a lot to discuss. It's like I'm telling you what you need to do, and explaining everything. So the first thing is Microsoft Teams. This is our main communication method. It's just like Slack if you've ever used it. But you can think about it as like a messenger group chat where you can also keep everything. So you can have your homepage. You can have like here. This tab is called Energy Systems, and it's literally what you're gonna see, like in this picture here. You click that, it'll take you to the OneNote, which kind of looks like this. So this OneNote over here actually has a section called Energy Systems Meetings, and our agenda will be there. I would try to be as diligent as possible about it. If I so also I will add sections for you guys, and feel free if you look at the agenda and you're like, oh, I have something to talk about, add it in there for the next meeting, or you want to talk about something in the meeting, put it down there. If you have if there's something important from this meeting that happened today, put it down there. If you're on a team working on the low voltage battery pack, you came up with the idea or a concept and you just drew it out, say on a piece of paper or something, put the picture in there. You want to write down some notes about how you did a certain calculation, you came up with with a back of the hand estimation number about how long a battery is going to last, put it in there. Use the OneNote. This is going to be our central source of information so that we can communicate stuff with each other and other people can see the work that you did. It also gives me a chance to look over the stuff that you have done, help you out so that you don't have to like send me just a boatload of pictures of like the work that you've been doing, so I can try and figure out like what's the problem you're trying to have, what are we trying to solve here. And there's a general chat there, which is under posts. They just call it posts. I don't know why. Feel free to ask questions there. I'm going to be asking questions there sometimes. I'm always posting stuff there. You say you came up with something really cool. Like I had that CAD model. I put it in there. You came up with a CAD model, or like you did something and you think it's cool, you want to share it with the rest of the team, put it in there. You need help with something, ask there. Everyone on the team here is a very talented, we have a group of very talented people who all have a large range of different skill sets. So I'm going to stress this one more time. Please use the OneNote. And if you're there at the energy system, at the all electrical meeting, or the general meeting, Sasha said, please use the OneNote. And I think it's a pretty good idea too, to keep all our ideas, our work, and all our progress there. And I will try to be, again, diligent about the meeting minutes. If I haven't put them there yet, feel free to add some. There is a template at the very bottom. And if I haven't, or if you want me to, just like literally poke me, send me a text. Hey, we have our meeting coming up and I haven't seen the agenda. Literally DM me that or put it in the all chat and I'll do it, poke me. Asana, I know I had assigned tasks there, but right now the way that we're moving forward, because a lot of you are going to be doing design work, it's not so much that we can break up those tasks on Asana, but we will assign and try to keep track of stuff there in the future. So these will be your sub teams for the next month, sort of. And I say a month because that's about how long I think you would need to make some decent progress on this before we come back. So for you can see your different teams and who you'll be working with. So I kind of set it up such that, and this was also not entirely intentional, but it kind of worked out. The people that would be in a team together are almost always going to be in the same time zone. Actually, yeah. So they're both in the same time zone. I think that I don't know what it is. I know they're in the same time zone. That's exactly 12 hours apart. Yeah, everyone else is in Toronto time. So yeah, Kardike, you'll be working with Junseo to design the inverter control systems. But when I say design, it's not so much like you don't have to design it from scratch. A lot of the work has already been done. You just got to figure out how it works, and then
Got it.
yeah, I'll go over it later.
Okay.
Yeah. So just a quick briefer. Yeah, get to know these people. They're your friends. You're gonna be working with them a lot in the future. I mean, over the next month. You know, get to like ask them for help, set up meetings with them. You guys should be communicating with each other, and then, for example, if you're in the low voltage power distribution team and there's a certain spec of something that you need to know, ask the low voltage battery design team. They'll probably know because the low voltage battery feeds directly into here. So if there's certain things about how the power distribution is going to work out, and there's certain things that you're not too sure about, these guys probably might know something. Charging system, for example, you need to know, oh, what are the specs of the high voltage battery or the low voltage battery, because you'll be designing a charging system for both of those. Ask the people on the LV battery design team, or ask the people on the high voltage battery design team. Again, you can come to me and ask me for questions and help or information, but I might not always be the best resource. I would argue that there are some people here that are, you know, that have much more knowledge in certain things than I do. And also, I'm just not always going to have the time to give you the best answer. So, yes, talk to each other, please. So,
Wait,
LV,
KG,
yes.
what am I doing?
Well, you said you're busy with PEY. If you want me to assign you to something, I have some stuff in mind for you.
Okay.
We'll talk about that later, you and me one-on-one.
All right.
So the low voltage battery design team will be comprised of Harsh and Mayank, as I stated earlier. So a lot of what you'll be doing is kind of here. You're kind of on a 2, 3, 4 stage mix of the design process. And when I say this, what I mean by that is that, you know, design is an iterative process. You get to the CAD and you start with the refined design and diagrams. You draw the block diagrams like I've shown here. You get to part sourcing. You're starting to buy parts. Say you realize, oh no, it's not going to work. We can't get this part. Or like if we were to try and get this part, it's like too expensive. Go back to the drawing board. You go back to step 2. Or say you get from step 2, you go to 3, and you're like, oh, we have all these parts that we're thinking of using. And you can kind of do 3 and 4 in parallel. Then you start to try and put them together, and then you realize like, yo, that's a lot bigger than I expected, or that's a lot smaller. Yeah, that's like way too big. And maybe you have to go find a new part, or maybe you have to just change up the design too entirely. I know personally, and you guys probably know, that design is an iterative process, and this has gone through many revisions. It is actually, this isn't even the final. There's actually another thing I added, but I didn't include it in here. So a lot of what you guys will be doing, it's literally all written up in here. It's what you need to be finishing up and doing in the next month. If you have any questions about that, you know, again, you can ask me. You can ask the other members of the team that you think have experience in PCB design, or like Easy EDA is literally just a circuit drawing fucking tool, which is just really nice. So yeah. Now, low voltage power distribution team. So the low voltage power distribution team, you guys have already sourced 24 volt boost buck converter and regulator combo. At first, we're gonna go with 2 separately, but found a really nice combo that's not too crazy expensive, and I guess that works out really well. And you guys have also started to tabulate all the power distribution requirements from the different subsystems. And so from there, you should have a rough idea of what are the power requirements for all the remaining converters. You know, what current are they going to be able to have to handle? And so you might ask why. At first I said boost buck converters, but you know, I realized that this battery pack never actually goes below 15 volts. So all of these will just be buck converters. And in order to smooth out the current after that, we're going to the voltage after that, we're going to use 12 volt regulators, just because a lot of the electronics are really sensitive, and so it's important to have those. If you can find combos, just like you did for the 24-volt rail, that would be great too. We just got to evaluate them, make sure the cost is good. And, at the end of the day, we still have to test them in the lab to see how well they smooth out the large jump in voltage. All right. Yeah, and you guys are kind of more on the stage 3. You don't really have to worry about this jumping around too much. The design is pretty straightforward. I can't imagine that this could change very much because we don't really have a choice. There are electronics at 24 volts. There are electronics at 12 volts, and there are electronics at 5 volts. We can't change that. And this design process, I will actually create another page on the UTHT homepage that will help you. We'll have a little description about what's going on. So the charging system. So this is kind of like a new subsystem within energy systems because charging had always been a afterthought, and we never really thought. Well, we did have a couple talks about it, but we never really formally started to approach the problem. So you guys are going to be really starting from scratch. Rayon has already started to do a lot of groundwork on this, but you will be joined by Asir and Esther, and yeah, you guys will be designing a platform and charging system for the low voltage and high voltage battery packs. And the way that's going to work is that I guess you can use pretty much the same methodology to charge the high voltage and low voltage battery packs, just because their voltage ranges are not too far. The high voltage module is about 29.4. It's about 30 volts, and then the low voltage module, you can charge it at 24 volts or something like that. So it wouldn't be too different. I guess it would be nice if so what you guys are going to do is you're just really going to start to investigate what the initial design process would be. So just how can I do this, period. And then from there you add on, maybe you add some safety features like reverse voltage protection for your charger, so that when your battery does get to full, or if your battery gets a little too much juice, it doesn't, or say someone connects like a fully charged battery the wrong way around to the charger for whatever reason. I know we're going to design to make sure that doesn't happen, but say that happens, we have the protection built in for that. It doesn't kill the charger. Maybe we want to add controllable current, so charge current, so that we can see what's the optimal way, or how does the battery perform under all these conditions. Someone not muted. It's a lot of feedback. Okay, so next team, inverter control systems. So you guys, this is a big undertaking too, because we're not so much at the initial design and investigation. We already know kind of what has to be done. We only have to worry about, but it's more of how are we going to implement this in our pod. So you will see that each of these systems that I've outlined here that control the inverter they have wiring diagrams on the inverter documentation. It's a really big manual, user manual. I know it's a lot of reading. Even every time I look through it, I find something that I didn't see before, just because there's a lot to do. But you really only have to focus on these 6 main sections I've put down here. And yeah, so Chunxio, Jun, you've already had a lot of, I guess you've read through it. I don't expect you to have read through the whole thing yet.
Yeah, I mean, I focus mostly on the pre-charge circuit for now.
Yeah.
It seems that everything else is everything else is controlled, because we don't have like throttle pedals and whatnot.
Right.
And I'm assuming most of that control is going to be done by the Odroid. So definitely gonna have to talk with software.
Yeah, so you guys are going to collaborate a lot with electronics and software. And so I'm going to try and set up, so, feel free to reach out to them too if you want on your own. I have already talked to the software lead and the electronics lead. I've given them the documentation, and they are also setting up their own team on how they're going to make this happen.
Okay.
So essentially you guys will be trying to figure out how we're going to design the breakout board for the control systems electronics, because June, I've already explained to you about the amp seal connectors and stuff like that, right? So
Yeah.
you can discuss with Cardicate, and you can guys both look over the documentation and start to just drop some plans or write a process of how it's supposed to look, how we should do it. What's the best way?
Yeah, for sure. I mean, I guess we can start off with just designing, because we're gonna need the breakout boards and the pre-charge circuit regardless. So we'll do that
Yeah.
first, and then that'll facilitate the electronics and software team with debugging and testing. Because
Okay,
it'll,
yeah. And like again, there's like a lot of circuits that need to be like built, like you need to get parts for. So if I'm not wrong, so you definitely want to help, like leverage the help of electronics to just like, you know, do that too.
Yep, exactly.
All right.
All right, so you guys can set up a meeting again, like I said, on your own to discuss the details of that. So next we have the high voltage battery pack. That'll be comprised of me and Brian, or Brian and I, depends on how you like the grammar. And we're also kind of just like the low voltage battery pack design team. We're going to be working on stage 2, 3, 4, sort of where, you know, we keep going back and forth. And just to show you part of that, you know, how I showed that I was going to power the Arduino. So the Arduino actually needs to, so this diagram shows another like stage in the process of the design process, I guess. Here I added a full wave bridge rectifier, and this allows us to power the there is gonna be a boost buck converter here, but actually no, just a buck converter here, but I just didn't add it yet. And this is just the diagram to how we're actually powering the Arduino for the battery pack. And this allows us to power the Arduino when the battery pack is discharging, but also power it when the battery pack is charging. And it will not kill the Arduino. Hopefully, I haven't tested it out, but I ran a simulation and it looks good. So yeah, this is what we'll be doing for the next couple months. We've already started testing with 660 ohm resistors, but we found that the voltage drop was slightly off than what it was supposed to be expected for the temperature sensors. And so we're going to try with a different range. This is on the recommendation of Brian. Still have to source those. We need to update our schematics with all of these. I'm going to start to update the block diagrams to include this new redesign and redo the drawing in draw.io. And draw.io is a really great tool to make just block diagrams to show how stuff is supposed to flow. Information is supposed to flow, power is supposed to flow, stuff like that. And we're also going to continue with the control software development of the Arduino. This mostly, Brian's going to be doing a lot of this, and I'm going to be doing all the rest. And Brian's going to be helping me write the safety and testing protocol for the technical testing protocol, so that we can give to the university and say, hey, we know what we're doing when we go into the lab to test this system. And that's pretty much it. Okay. Not bad on time. So, any questions? I'll put it here. No questions. Okay. I guess I should have done this first. I didn't even follow my own agenda, but I'd like you all to, you know, introduce yourselves to the rest of the team so we can get to know one another. Yeah. Start with Asir.
All right. Hey guys, I'm Asir. I'm third year ECE. Yeah, I'm joining Hyperloop this year because I was in Concrete Toboggan before, but now I feel like my interests are changing, and so that's why I'm here now. And as Kiki mentioned in the slide, I guess like part of the reason was I was able to do some research with like electric vehicles and batteries this summer. So yeah, it's pretty cool. I'm excited to work with you guys.
Truman.
Hi, I'm Truman, Chem 2T1. I'm currently on PY, and I was on the team last summer, and I'm just kind of chilling here. Yeah.
Esther?
Hi, can you hear me? Yes. Okay,
Yep.
I'll turn on my camera just really briefly. Hi everyone, my name is Esther. I am a third year EngSci in the energy system option. And yeah, I am joining energy systems with Hyperloop this year because I want to learn, I guess, more technical skills aligned with my major. So yeah, excited to meet with you and work with you.
Mayank, you go.
Hey, can you hear me?
Yes.
Yeah. Hi. My name's Mayank. I am a Chem 2T2. And I've been on the team since last year. And this year I'll be working with Harsh to design the low voltage battery. I'm sorry I missed the first half of the meeting. I was like busy. But it's nice to meet you guys.
Rayon. Also, guys, the order is posted in the chat, so just watch out for that.
Hello, my name's Rayan, and I am in second year EngSci. I joined the team earlier during summer after being asked by Kiki.
Hey, I'm Harsh. I'm Chem second year, and I've been in the team since last year. Yeah, it'll be fun working with you guys.
Hello, my name is Kartike. I'm an EC 2T3. This is my first year in UTHT. And I'm mostly joined because of my interest in electrical. I'm looking forward to working with you guys.
Hi, I'm June. Mac 2T1, currently on PUI. Joined this summer because I've been working on an electric car conversion, and I wanted to kind of put those skills into a more formal design team, essentially. So yeah, this is gonna be a good year. Looking forward to working with all you guys.
Hey, I'm Brian. I'm a ECE 2T2. Just joined this summer. I'm interested in all the stuff we're doing, so hopefully it'll be a lot of fun.
All right. Yeah, we got two other members. Unfortunately, they can't be here with us today. But good meeting. I know that, so we're about a half-hour mark. Those of you who want to leave because you want to for your mental health or whatever. I know that meetings and stuff can be tiring, and I know that they're not always the most productive thing ever if you're just all sitting there, not really being able to do work. But please meet with the other members in your sub-team. Again, it's still on this slide if you're not too sure. And all the meeting minutes will be posted on the OneNote, which again, please use the OneNote. But I know that Harsh has some updates, and I know that June has some updates.
Yeah. So Mayank and I have been coming up with a redesign for the battery pack.
Do you want to share screen or?
Yeah, I can share my screen. Yeah. So what I was thinking before was a simple cuboid shape, but to save materials, like for example, they used to use like nickel strips, and they used to use 2-cell battery holders. Now we're trying to change it to sort of this shape. This is a technical drawing of how the battery might be. And so from the top view, you can see 3 4-cell battery holders now, and then the BMS and the Arduino on the side of that. And so each cell holder has pins on the sides, so that we wouldn't need to use any nickel strips or anything in between. It would just connect directly to each other. But we still have to work out how to connect each cell in series and parallel to make the final formation a 6s2p battery. But other than that, after we figure that out, we just need to update the manufacturing protocol document to show how to connect the BMS wires and everything. It looks like we're on track. We just need to figure out the wiring. Yeah.
Awesome, that looks really good. Yeah, so the pins on the side of the holders, you can like literally just put wires on. Like we can solder wires onto those and then put some heat shrink around it, and it's good. And you can hook those up however you need.
Yeah, we're gonna have to like check the wiring though, because like series is like relatively easy, but like we're really unsure how the parallel wiring would go. But apart from that, like it shouldn't be too hard to like wire this. So I think like most probably this is like will be the design in the end.
Awesome. Yeah, I think another thing you might want to indicate is which is the positive and negative sides, since we still do have to do the wiring for the parallel and series. So
Yeah.
indicating that on this diagram, once you've got that sorted out, it will be good.
Yeah. After we wire it, we'll make it more detailed. This is like the first draft, if you will.
Okay.
Yeah.
Looks good.
I guess it's my turn. I don't really have anything in terms of presentations or documentations to share. This week at PUI, and my placement has been super busy. But anyway, the plan is roughly, briefly, like I briefly mentioned before, to start off with the pre-charge circuit. There is some documentation on the user manual. Cardicay, if you want to check it out. I don't know how far you've gotten in reading the user manual, but there's some documentation on there, some specs that we can follow. So the plan is to start off with the pre-charge circuit, because without that, the pod won't move at all. And then we can start worrying about connecting, how to interface with the controller through the amp seal connectors, which I don't think will be too difficult. Even PCB design shouldn't be too complicated. And then the rest is all just going to be software and electronics integration. So we're going to have to coordinate that separately. But that's the plan. We're just going to be starting off with the design work and then handing it off to or working with software.
Okay, got it.
Yeah, Carter K, I'm sorry. I know I gave you quite a bit of reading to do with this next task too. However, I know you have experience with creating circuits from just diagrams and not working with too much of that information. I hope you can use those skills here.
Yeah.
Also for all the new members, at the end of your 1 month, you can come, that's your like trial period. You can come to me and say, hey, I liked working here. I want to continue. Or you can say, hey, I don't like working in the team. I don't want to be part of UTHT anymore. That's completely okay. That's just a heads up. So I think that would be, well, June, you're still here after a month, so I'm going to assume.
Yeah, and then I'm sticking around.
Yeah. And same with Rayon. All right, yeah. Good meeting. We don't have to stick around, but that was good. I like that. The quick fire updates. Just quickly, those who gave updates, if you can put it down in the meeting minutes, I will try to be better about putting those down myself. But if you can put those down in the OneNote and meeting minutes, that would be great.
Sounds good.
Yeah, sure.
All right, have a good weekend, everybody.
See y'all.
All right, take it easy,
Thanks,
guys.
Kiki.
Bye.
Bye bye.
All right.
Thank you.